Okay, so the next part, and actually this is going to be pretty quick because there's only really one page of this. So now that we understand matter, okay, so we have mixtures, we have pure substances, and now we really need to understand physical and chemical properties. So physical and chemical properties, what it's going to come down to, and you're going to ask yourself a simple question. So a physical property is something that essentially is going to help, you're going to be able to define it without destroying the substance. Physical property is something that can be determined without destroying the substance. And I really should say pure substance, right? The pure substance. Okay, so the best example that I can give of this is a physical property is something that is innate to that chemical or to that compound. So if we take a look at water, okay, I know that water boils at 100 degrees Celsius, okay? How do I determine that? Well, what I do is I take water and I boil it and I pop a thermometer in there and I say, oh, it's boiling at 100 degrees Celsius. Okay, so I know the temperature at which pure water boils at. Did water change? It did change because it changed phases, right? It was a liquid and it boiled and now it's turning into a gas. It's going off and boiling away. But it didn't change what it was chemically. It was liquid water and then it became gaseous water, but it was still water the entire time. So when you're looking at a physical property, we're looking at something that can be determined without destroying the substance. Really what we're looking at is there a phase change or a phase change, a physical change involved. Okay, so there's a couple of ways that we can look at it. So is there a physical change involved? Okay, so that is really what a physical property is, right? Water is, colorless. We can observe that water is colorless. That is another one. Water is clear or colorless. We can observe that water is clear. That's a physical property of the substance without reacting it, right? Without destroying what it is. The water is still water, although you're making the observation that it's clear. Okay. But a chemical property will be determined by destroying the compound. Okay. So if we take sugar and I react it and I burn it, it burns to form, let's see, CO2, carbon dioxide, and water. I know that I can just take a flame to sugar and it catches on fire. So sugar burns. Okay. In fact, I don't even need to say the rest of this. Sugar burns. Okay. That is a chemical property. Sugar can be caught on fire and it will burn. Okay. Or if you tasted it, sugar tastes sweet, right? You have now consumed the sugar, although you could probably get it back. That's kind of but that's a chemical property of it, right? A chemical property is something that is going to destroy it. Sugar ferments to form alcohol. Okay, so these types of things, if you have something different at the end, that is going to be a chemical property. Okay, so it's a reaction is involved that is going to alter the chemical. It's no longer the same afterwards. Okay, so of these properties, we have different, in terms of physical properties, things that are really important to us are going to be things like um, density. Density is an important portion of the physical properties of a substance, okay, because it helps us define what it is. There are two different subtopics or types of things that we call specific properties: intensive versus extensive property. So an intensive property is independent of the amount present. okay? Extensive is going to be dependent. Or I guess I should say of or on the amount present. The examples that I can give you for an intensive property. Okay, so intensive property, independent of the amount present, the best example is density. Okay, so density doesn't matter how much you have. If I have 1 liter of water or 4 billion gallons of water, the density is always going to be 1 gram per milliliter. The density is always the same. If I have 1 ounce of gold or 2 tons of gold, the density will always be the same. Okay, so that's an intensive property. So what other intensive properties can you think of? And so that's what I'm going to ask next time. What other intensive properties? What other intensive properties are present that you can think of? So density is a property, boiling point, freezing point, melting point. What else? Mass, volume, anything that you can measure is going to be considered a property. Okay, so we can measure mass, we can measure volume. And that goes into our next part. Dependent on the amount present, volume is considered a dependent property. Okay, so it's dependent on the amount present, or an extensive property. So it depends on the amount present. If I have 1 liter of water versus 10 liters of water, those are going to be different volumes. Therefore, it depends on how much I have present. Okay, what other extensive properties can you come up with other than volume? Okay, so let's talk about those. Okay, so the last little bit, and I actually mentioned this above, is a physical change versus the chemical change. And we really mentioned it when I was talking about physical versus chemical property. A physical change is same thing as a physical property. It is a phase change or a change where, that's terrible, where the compound remains unchanged. What we're really looking for is solid to liquid to gas, or liquid, some version of a phase change, going from liquid to gas, or some version of a phase change. A chemical change is going to be it's just simply a chemical reaction. This is the quintessential chemical reaction, and RXN is usually what I use for reaction, so a chemical reaction. As in, I start with something and I have something else at the end. So a chemical reaction, or the substance is changed. It is no longer the same substance at the end. Okay. And I mentioned this above, but I can separate a mixture into pure substances through physical processes. If I wanted to separate sand from water, I can just filter it, right? Nothing is physically changing. The sand is still sand, water is still water. But if I wanted to go from a compound to an element, this has to be a chemical change. So I have to burn it, or do something to turn it from a compound into an element. Okay. Okay, good. So classify the following as a physical or chemical change or property. We're going to talk about the differences between property and change, but for the most part, just tell me, is it physical or is it chemical? That's all I really want to know. I don't really care about the change or property part. That's not as important. It's just, do you know if it's a physical or a chemical change or a property? Physical or chemical? That's what we're looking for. Okay. And so we're going to get into the next chapter in a little bit, but before we do that, and we're going to go through all of these together, I just want to go through one last thing. So if I have a solid, I have a liquid, and I have a gas, do we know, and don't look this up, try to come up with these the best you can, and we're going to cover them in class. What is the transition called from solid to liquid called? Going from a solid to liquid, what do we call that? How about from liquid to gas? And how about going in the other way? If I have gas going to liquid, what do we call that? Please don't look these up. Really, it's no problem. We're going to go over them together. How about liquid to solid? What would we call that? And then finally, there's two others here. Solid all the way to gas or gas all the way to solid. What are those different types of phase changes? And we're going to say those are phase changes. Phase change terminology. What do we call going from solid to liquid, liquid to gas, or back, or solid to gas, or gas to solid? So try to come up with those, and we're going to work on those together in class. All right, great.